Now in terms of side, which side is this? B is the opposite, and then over the A, which is the adjacent, right? Now I know some of you have learned a cute little saying to help you remember these. Who's learned it? What is the saying? SOHCAHTOA. SOHCAHTOA. Let me write it down up here. So a way to remember these three trig functions is SOHCAHTOA. SOHCAHTOA. Many years ago, for Halloween, my girlfriend at the time dressed up as Pocahontas, right? And I told her that I wanted her to be SOHCAHTOA instead. You know, Pocahontas is like the name of an Indian girl or something like that. SOHCAHTOA to me also sounds like the name of an Indian girl for some reason. Native American. SOHCAHTOA. So what is nice about this? Sine is opposite over hypotenuse, right? Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So it's just a nice, cute way that you can remember these things quickly. You all see it? Sine, opposite over hypotenuse. Cosine, adjacent over hypotenuse. Tangent, opposite over adjacent. I'm not sure in 2022 you can dress up like Pocahontas now. Isn't that like, won't you be sued or something? Doesn't something bad happen to you? No? All right, we have three more trig functions. Three more. I've got good news. Good news is that the next three are just the reciprocals of all of these. So since sine was opposite over hypotenuse, what if you did it the other way around? So if I flip that over and did c over b instead of b over c, we get a new function. Anyone know what that one's called? When you flip sine over?
Like negative, you put like a dash 1 or something?
That's the inverse trig function, so we're not there yet. We will be an inverse trig. It's just the reciprocal. Anyone know what the reciprocal of sine's called? Cosecant. Okay, so I'm going to put it right underneath these because they go kind of together. They're reciprocals. The cosecant function, that's the way we write it, cosecant. Look, I didn't make the names of these up, all right? So the cosecant function, what we do is we write c sc theta. All it is that one flipped. So it's c over b. Or if you want, you could also, in terms of like the SOHCAHTOA thing, you could say that it's hypotenuse over opposite, right? It's the hypotenuse over opposite. But there's one other way you should also remember this. This is also just the reciprocal of the sine function. Right? Isn't taking a fraction and dividing it, you know, taking 1 and dividing it by a fraction, isn't that the same as the reciprocal? Yes or no? Yes. If I take 1 divided by sine, so imagine I took this b over c and did 1 divided by that. 1 divided by b over c would flip it and become c over b, right? So that c over b is the same as the reciprocal of sine. All right, that's the cosecant function. It's the reciprocal of the sine function, so it's everything here flipped over. Then we have the reciprocal of the cosine function. Anyone know what that one's called? Secant. The secant function. And the way we write it is sec theta. It's just c over a, or if you want, it's the hypotenuse over the adjacent. Or you could write it as 1 over what? Cosine. So look, notice how right here I wrote cosine theta and I didn't put the theta in parentheses. Y'all see that? I didn't put theta in parentheses. That's okay. Okay, it's okay to not have it in parentheses, but just understand that like the thing that goes in here is your argument. That's usually your angle. Parentheses are not required, but it's a good habit to put them there. In calculus, I never throw parentheses around these because it's just a waste of time. But it's not bad notation to put it there. Any questions? Secant is this flipped, that flipped, reciprocal of cosine. That's SOHCAHTOA. The SOHCAHTOA is only for sine, cosine, tangent, right? Sine, cosine, tangent. If you want to know what cosecant is, there's not like a cute little thing we have. You just have to remember it's this flipped over. So if I want to know cosecant, I'd say, oh, it's the reciprocal of sine. I'd have to know that. And then I'd say instead of opposite over hypotenuse, I'd say hypotenuse over opposite. Last one. What's this last one called? Cotangent. And all the cotangent function is the reciprocal of tangent, right? So we write COT, theta. It's A over B instead of B over A. It's adjacent over opposite instead of opposite over adjacent. And it's the reciprocal of tangent. And that's it. Those are our 6 trigonometric functions that are defined by a right triangle. And now what I'd like to do is I'd like to give you a triangle, and I want to know what the value of all 6 trig functions are for this particular triangle I'm going to draw. SOHCAHTOA. All right. So let's say I give you this triangle here. Right triangle. Let's say I tell you this side here is 6. And I tell you this side here is 11. And here's theta. I want us to find all 6 trig function values of theta. So that means I want to know what sine theta is, right? I want to know what cosine theta is. I want to know what tangent theta is. I want to know what secant, cosecant, cotangent, all 6, right? All 6. So what do you think the first thing I do should be? Find the missing side, right? I have one side of this triangle I don't have. Once I have that, then I can just use the SOHCAHTOA and get everything, right? All right, so let's call that side B, right? It just kind of makes sense to call this B. All right, let's use our Pythagorean identity. 6 squared plus B squared must be 11 squared, right? Which means 36 plus B squared is 121, right? Subtract 36 on both sides. You get B squared is what? What's 121 minus 36? 85? And now we take the square root on both sides. So B is 9 point, right, decimal, right? We're not going to use the decimal. We're just going to leave it as square root of 85. And that's fine. We can just leave it there. Since it's not a perfect square, we're just going to leave it. Now, do you remember this back in whenever? When you'd have something like, well, let's see. If you had square root of 16, of course, we'd just say 4, right? But if we had square root of 8, one thing you could do is you could say, oh, that's square root of 4 times square root of 2, right? And then you say, oh, the square root of 4 is 2, and you say 2 root 2, right? So the square root of 8 is the same as, square root of 8 is the same as 2 root 2, yeah? In this class, for me, you can leave it like this. Because for the same reason that we had that long discussion about why this is the same as this, and rationalizing the denominator is just an older, outdated thing, this is kind of the same thing. These are the same two numbers. I don't need you to pull out a 2. I know root 8 is 2 root 2. Just leave it, okay? So once you're here, just leave that. And that's that side, okay? That's the side right here that was missing. Square root of 85. All right, once you have all three sides, I mean, you're almost back in grade school at this point, because now we're just going to write things. Sine theta. Sine is, let's see. Let's get every table involved. So anyone off that table, give me sine theta.
Square root of 85 over 11.
Square root of 85 over 11. That's so, right? From the SOHCAHTOA, that's so. Opposite over hypotenuse. All right, next table. Back table in the middle. Cosine. So ka. 6 over 11. Adjacent over hypotenuse. Good. All right. Middle table, middle. Right? Did I ask? I haven't called on you too. No? You want this one? Tangent theta? TOA. SOHCAHTOA.
85
Root 85
over
over 6. There you go. Everyone understand where these are coming from? All right. Moving along. Back, left side table. What's the reciprocal of sine? What do we call that one? Cosecant. So I write CSC theta, right? You want to give me what cosecant is? 11 over root 85, right? Do we have to rationalize this? No. The online homework system will probably want you to, but it should accept that answer as well. We'll see. It doesn't? You're shaking your head.
It'll say like the answer is equal to the correct answer, but it'll make you break it down.
Will it? So on a test, I don't care if you leave it like this. The homework system's the homework system. I can't change it. All right. Who's up? Middle, left side. What's the next trig function that you want to give me here? Reciprocal of cosine? What do we call that one? Secant. So secant of theta is 11 over 6, right? We're just flipping those fractions over. That's all we're doing, right? And last one, cotangent theta, 6 over root 85. There we go. Those are all of the 6 trig function values for, yeah. How are we doing time-wise? 15 minutes? Got all 6 trig function values. All right, I'm going to give you another one. You ready? This one's harder. On a right triangle, sine of theta equals 7 over 9. Find the 5 remaining trig function values. Now there's something very subtle here, something very subtle that's going to come up on your homework when they give you the wording for the problems on the homework. They're going to tell you, hey, theta is an acute angle. Acute, not cute, like, oh, it's cute. Acute means less than 90 degrees. When you think about a right triangle, if we call that angle theta, or even if we call that angle theta, do you agree that both of these angles would have to be less than 90? Because one of them is already 90. So if that's 90, then that's already 180. You don't have enough degrees left for anything else. So to say that to say that your angle theta is acute is the same as saying that that angle lies in a right triangle. Make sense to you? So I'm telling you, on a right triangle, sine of theta is 7/9. Find the rest of them. Find cosine theta, tangent theta, secant, cosecant, cotangent. So how do you think I'm going to go about doing this? Draw a triangle, right? Let's draw a triangle. And then use this, right? Do it. No? It's gone? Okay. So here's theta. I'm going to draw a triangle. So sine is SOHCAHTOA, right? So it's opposite over hypotenuse, right? Opposite over hypotenuse. So this is my opposite side. This is my hypotenuse side. So I can label this triangle with my opposite side being 7 and then my hypotenuse being 9. Do you see that? And now that triangle is a visual representation of that what was given to me. Do you see it? And now what? Go find that missing side, right? Go find the missing A. And then we'll be right back where we were on the previous problem. So let's figure out what A is. So A would be A squared plus 7 squared equals 9 squared, right? And that means A squared plus 49 equals 81. Subtract from both sides. A squared is, what is that, 32? So A is the square root of 32. So I'll just put that here, root 32. And then once you're there, you have them all, don't you? It's just all the different, SOHCAHTOA, and then flip them all over. Do I need to continue, or you think you got it? You got it? Got it? Okay. Let me give you another one. What if I tell you that theta is acute? Is acute angle. It's so cute. Okay, and then I tell you that cotangent theta is 4. And I ask you to find all the trig functions, all the remaining ones. Find the 5 remaining trig functions. How would you do this? Start with the picture, right? Like this. Theta. Flip. You want to flip that? Let me ask you something. That's the flip of what? Yes, but I'm saying cotangent is the flip of what? Tangent. What is tangent on the SOHCAHTOA? Opposite over adjacent. So that's what over what then? So I'm thinking this is the reciprocal of tangent. SOHCAHTOA is opposite over adjacent. So this is adjacent over opposite. Do y'all agree? Can you look at 4 as a fraction? 4 over 1. 4 over 1. Do y'all see that? So from here, so I could have done the tangent. I agree, I could have done that. But do y'all see I don't need to? I can just do the reciprocal of opposite over adjacent and do adjacent over opposite, do 4 over 1, and then label it. So my adjacent side would be 4. That's this side, isn't it? And my, wait a minute, oh yeah, opposite would be 1. That's this side. Do y'all see the visual representation of that relationship? No questions? What are you missing? The hypotenuse, right? C, right? Can you get it? Yeah, Pythagorean, right? So we go 4 squared plus 1 squared equals c squared. Notice on this one, because we're solving for c, we're just going to figure out what this is over here. Like we don't have to move anything over. So it's just 16 plus 1 equals c squared. That's 17 equals c squared. So c is root 17. Bam. Once we have that, we're in business. Okay? All right. This table, sine theta. Sine.
One over root 17.
1 over root 17. Good. SOHCAHTOA, right? So, opposite over hypotenuse. Good. Cosine theta, this table. Cosine theta. Take your time. I'm not trying to rush you. But hurry up.
4 over
Root 17? Okay. This is going to be something you want to start to wire into your brain. Sine is this and this, right? Cosine, this and this. Tangent, this and this. Well, I should say it another way. Sine, this over this. Cosine, this over this. Tangent, this over this. You're going to start to get used to just, that becomes automatic. You won't even need the SOHCAHTOA at some point. It's just, you just know it's. All right. And then the next three would just be the reciprocals of all those, right? What's tangent theta? 1/4, right? Well, that's the reciprocal of this, right? So, but it matches, right? It's this over this. Okay. I think you get it. I think you do. Do we have questions on it?
So for your equation, you want like the root 17, just leave it like that, right?
Yeah. Yeah, don't use decimals. Definitely, and don't worry about rationalizing. All right. I want to draw you something. Yeah. Okay, ready for something cool? It's relative. I don't know if you'll really think this is cool or not. Let's go back to this picture that we all took on faith in the very beginning of the class. ABC, right triangle. Nobody complained. Everyone was on board. The Pythagorean identity, right? A fundamental identity from mathematics, right? So if we have the angle theta here on this, do you all agree that I could take this equation, if this is a true equation, which we were saying is, that I could divide everything by c squared? Would that be legal? As long as c is not 0, right? I can divide everything by a number other than 0. So imagine me coming in here and dividing everything I see by c squared. So that's all right? Y'all are okay with that? All right, the right side of this equation becomes 1. All right. A squared over c squared, isn't that the same as a over c squared? That's what it means. And isn't this b over c squared? Yeah? All right, now think about trig functions. A divided by c. What trig function is that? Adjacent hypotenuse. Cosine, right? Go back and look at your definition. Wasn't cosine of theta, wasn't that equal to a over c? Yes? So I'm going to replace a over c with cosine of theta, and then that thing that needs to be squared. Do you all see that? Plus, now what's a over c? B over c. B over c, by definition, was sine. And so this is sine theta squared, and that must be 1. And that is your first and the most important trigonometric identity in this class. Right? This thing's going to be with you for the rest of the way. I'm going to write it in a slightly different manner. I'm going to write it like this. Cosine with my squared there, theta, plus sine with my squared right there, theta, equals 1. So notice my usage of the squared here. This is one of the most confusing things in our notation with pre-cal stuff, is that if I want to do the cosine function and square it, I can put the 2 right between the s and the theta, and that means the same thing. So this notation means this. I'm going to say that again. This notation means this. Let me say it one more time. This notation means this. It's just notation, right? And then the way you will see this in most textbooks is because it's addition, they'll write it this way. This right here, burn it in, all right? Go get a tattoo. Go get a tattoo. Just get right on your arm, all right? If you have any permanent tattoos of math formulas, you can use them on the test. That's fine with me. No? Someone's going to come all tatted up next class and we're like, shit, I was kidding. That's it. That right there is our first what is called Pythagorean identity. It's called Pythagorean because it comes from the Pythagorean formula here. So how did I get this formula? I started with this, right? And I decided to divide everything by c squared, right? Why c squared? Could I have done a squared on everything? Yeah. Could I have done b squared on everything? Yeah. So let's do it. Let's start over. And let's, instead of dividing through by c squared, let's divide everything by, let's go with a squared. What would happen if I divide everything by a squared? One plus, okay, this is going to become b over a squared equals c over a squared. What was b over a? Go back and look at your trig functions. What was b over a? Tangent, right? So this is actually 1 plus the tangent function squared. And what was c over a? Let's see. C over a, wait a minute, that's the reciprocal of a over c. Secant. Yep. This is secant of theta squared. You have to have the squared there, right? Because it's squared. That is your second Pythagorean identity. 1 plus tangent squared theta equals secant squared theta. I cannot tell you how much in Cal 2 we use these. So much. And then there's a third one that you would get by dividing everything here by what? B squared. Right? We've done c squared, we've done a squared. If you do b squared, you're going to get cotangent theta squared. I'm not going to go through this one. Plus 1 equals, any guesses here? Think about what would happen if you divided everything here by b squared. B squared, that's 1. C over b, what's c over b? Reciprocal of sine, so cosecant squared theta. Those are your 3, and this one again is by far the most important one. All right? Sine squared theta plus cosine squared theta is 1 always and forever. All right, on your homework, on the Pearson website, you have homework due. I'm going to look at it over there real quick for you. That's not it. We didn't get through everything. The stuff that I didn't do is not going to take us long in class next time, but I don't want you to worry about doing it. So let me just bring up the assignment real quick. Did you all get all those alerts yesterday or no? Yeah. I'm so sorry. I was about to throw my phone at myself. I didn't realize it would give you those updates, but I was having all sorts of trouble with this system. I did email and apologize. Preview. Okay, so here we go. I saw him when we walked out of class last time. That same guy.
I saw a possum at the hospital that I worked at. I thought it was a cat.
Okay, so look, you're only going to do the first 6 problems, right? Just the first 6. All of those problems, they give you some information, and then they ask you to figure out the other trig functions. And then we come back next class, we'll be able to do the rest, and they're not that bad, and we're going to actually start the next section. When's our first test? Next Tuesday. Oh, wow. So we should probably next class talk about the test, yeah? We'll talk about it next class. Yes? I did not take attendance, but we did a quiz, so I think that well, no, that won't count. It's 2:41. No, I guess I'm not doing it today. Y'all have a good day. Yeah. Let me turn my camera off. I've got to make a phone call before I can commit to anything here, but let me...
Mind if I use the restroom?
Oh, no, go ahead. I got to figure out what's my thing's been going on. What's he doing? Ooh. He's a little guy. He's a baby.